It's time to speak about physical layer, the last layer of the OSI model, which we are going to describe with you. What is the physical layer and what its functionality is? Let's first of all take a look for again this matryoshkas. So each of them represents the PDU, the different PDUs of the OSI networking model, starting from the data, or let's say if we'll divide them by the layers, it's going to be the application, presentation layer, and session layers of OSI model. Next one is representing the transport layer, network layer, and data link layer. And the last one is the physical layer. So after encapsulating our first matryoshka till the last matryoshka, we have some changes in the sizes of these matryoshkas. And at the end, we had with you the frame in data link layer, frame. And this frame goes to the physical layer, is represented as the binary stream. And afterward, this binary stream is encoded to the bit code. And afterward, it is actually goes to the signal. So some signals are generated on the physical layer. Okay, two fundamental functions of the physical layer. They are data encoding and the signaling. Let's take a look for them. What is the data encoding? So data encoding is the method of converting the stream of data bits into predefined codes. The codes are a grouping of bits used to provide a predictable pattern that can be recognized by both sender and receiver. And using predictable patterns helps to distinguish data bits from control bits and provide better media error detection. If we'll take a look for some of the advantages of using the encoding process, you can have such kind of situation that as a result your computer is going to send such kind of a bit stream. This is, for example, bit stream. And when your networking interface card will try to generate this bit stream, it will send much the same values without any changes. And in case when your bit stream is too long with the same values, it will be difficult to distinguish how many bits being sent on the receiving part, so that receiving device may have issue to evaluate how many bits being sent. And that one of the reason of the encoding is to provide the differences of the stream of the bit stream, so that the result you may have such kind of situation. Okay, so this bit's been represented as the bit code, and the bit code now have some differences. And also in the phase type of the signaling, you have limited number of the phases, so that is why you are not able to exceed the maximum amount of the changes in the phase. And so we'll speak about signaling a little bit later. And now some impacts of the encoding. They are reducing bit level errors, limiting the effective energy transmitted onto the media. There's like like in previous example, when you have a lot of ones and you have a lot of ones which you have to send, and your networking interface card has to generate the signals. Like when you have 1, then you have power on your like 5 voltages, and when you have 0, then it is like no voltage. And when you have a lot of ones, then you have to send a lot of signals without any changes. and when it will be too long, maybe your networking interface card will be heated, and maybe it can be broken even. So this is one of the reasons of using the encoding and helping to distinguish data bits from control bits. And when you are sending the bit stream, or let's say not the bit stream, the bit code, has its own combinations. For example, this combination will be used for the control, so this is control bits. And for example, this is also going to be control bits. And all other combinations can be just the data bits. So in case when you have encoding, then your device is distinguishing the control bits from the data bits, and due to that fact that you have this distinguishment, you have the better understanding between so not the between the receiving device will better understand the situation with the bits. What else? This is one of the example of the encoding process in which you can see 4B, 5B encoding. It means that input 4 bits and output 5 bits. So, and your stream actually increased for 20%. And this technology, so this encoding process being used in technology of the classical Ethernet of the with the speed of the 10 megabits per second. And as the result, we have, look, 4 bits are represented as the symbols like this, as a 5 bits, and all of them just it's just mapping. All right. And in case when there is such kind of bits are going to be signaled, before they will be signaled, they are implemented through the encoding process, and it happens like this, and 1110. So instead of sending this information, we will send this information. And at the end, when the receiving device will receive these bits, it will understand, it will make decoding of them by using the same table, and as a result we will have with you, and this actually is going to be our frame. Well, and also we have some control and invalid codes. They are looking like this. So if device is receiving such kind of combination of the bit code, it means that this is idle. The start of stream, like it's at the start of the frame, and start of stream, and end of stream, and end of stream. And some of them are invalid, they are not used. And transit error bits, bit codes are represented like this. Now let's take a look for the signaling. The signaling been used for a long time by the human being, and they've been used before the signals which been just smoke from the fire. And as you see here, I took it from the internet, like this is A, B, C, and so on. Okay, and nowadays we are using almost same algorithm, so we are just creating from the symbols some signals. And we have three main types of the signaling according to the different medias. They are electrical signals, which are used in the copper media. They are light impulse, which are used, this type of signals are used in the fiber optics media, and microwave or electromagnetical signals, which are used in the wireless communication. Alright, what is the signaling? The physical layer must generate the electrical, optical, or wireless signal that represent the 1 and 0. The method of representing the bits is called the signaling method. Alright, we have three main types of the signaling. They are amplitude, frequency, and the phase, in which we can see that the amplitude type of signaling, it is like when you have 0, there is no signal. When there is value 1, then this signal, like for example 5 voltages and 0 voltages, like, and if you have multiple ones, then it is like without change it comes. When you have 0, it is changing, and when it is 1, it's again changing. whereas the frequency is used with the algorithm of when you have 1 then there is the change, when you have 0 then there is no change in the frequency. In the phase it is like you have 1, then your signal is increased by the phase. When you have 0 it is decreasing once. When you have multiple ones then it is increasing. When you have 0 and increase one more time. Due to that fact that we have limit of our phase, we have to use also the encoding process which we described before. Alright, physical layer standards. We have some standardization organizations starting from the IETF and ending with the EITA. These standardization organizations are providing the standards for the physical equipments and for the signal types and so on. Well, the physical components. The physical elements are the electronic hardware devices, media, and connectors that transmit and carry the signals to represent the bits. And they are connectors, so that part of the physical hardware which is connecting the cable from one side to the port from the another side. They are called connectors. So we have different types of connector for different types of the media. We have cables, also different types of cables for different types of the media, starting from the UTP cable, which is abbreviation for the unshielded twisted pair, STP cable, shielded twisted pair with some shield. This shield is usually done by the foil. This in Russian is folga. Right, and it can protect from external interferences. So if external interferences are occurring, then these signals will be just mirrored. Okay, but in case when you have external interferences on the unshielded twisted pair, then this interference can impact to the signals and can damage your signals actually. Also, we have the coaxial cable. This type of cable is been also known as the TV cable for you, TV cable. You know, like there was the service like Alma TV or the Icon TV. They been using this type of cable to provide to you the services of the television. And also this type of cable been used in the token ring. It is old technology which been used previously in local area networks, and nowadays it's not used oftenly in the computer networks. And also we have the type of the cable. This is the fiber optics cable. Alright, now let's take a look for the interferences with the copper media. So what kind of interferences can be occurred? So when you have some fluorescent lights, they can make the interference, or maybe nearby there is the radio wave antenna which is generating the high signals, electromagnetic signals, or some electrical motors which are working nearby these cables. They can impact to your cables, and due to that fact that they can impact to your cables, it is not a good idea to use the UTP type of the cable here. It is better to use the STP cable, or it is better to use the fiber optics cable, because fiber optics cable is using the light signal, and when the light signals are in use, then electromagnetic interferences are not going to impact to work of the light signals. Alright, interferences protection on the copper media. So we have some elements of the interference protection on unshielded twisted pair, and they are so this twist is actually protecting from the interferences. And we have 4 pairs which are twisted, and their twists are different. For example, if it is twist twisted pair of let us say the white orange. So imagine that white orange and orange, they are twisted like this. And let me select the green one. The green twist will be not absolutely same. Its length and its position will be differently. For example, the twist will be quite longer, okay, like this. Okay. So if you'll open your cable, if you'll open this jacket of the cable, plastic jacket, then you will see that the twists of the cables of the pins are different, and it is actually one of the protection method of the interferences. Well, we have 4 pairs and we have 8 different colors, so we'll speak about them a little bit later, maybe right now. So unshielded twisted pair, as I mentioned before, consists of 4 pins and 4 pairs and 8 pins with different colors. And they are, so at the end of the cable we have a connector with the 8 pins, 1, 2, 3, 4, 5, 6, 7, 8, or maybe 1, 2, 3, 4, 5, 6, 7, yeah, 7, 8. And this type of connector is called RG45 connector, and this connecting to the port. For example, this is switch port or maybe the rotor's interface. Well, we have such kind of RG45 connector. It's done with the plastic with some metallic plates. So this metallic plates is cut into the cable. So when your pin is coming to this cable, metallic plates are cutting it inside, and afterward it is holding the cable, so that cable will not be able to go out from the connector. And what else? So we have 2 types of interconnectivity of our cable into RG45 connector. They are called 2568A and 2T568 and B. Whereas in A type of connectivity we have white orange is on the first pin, white green is on the first pin, and green is on the second pin. White orange is on the third pin, blue, white blue, orange, white brown, and brown. So connectivity is done like this. And if you'll take a look for B type of connectivity, so then we are starting here from white orange, orange, white green, blue, white blue, green, white orange, white brown, and brown. So if you'll take a look for the comparison, you will see that only pins 1, 2, 3, 6 are changed with the places on the both sides, and pins 4, 5, 7, 8 from the both sides are not changed out. Then we have 3 types of the UTP cable. They are straight-throw, crossover, and rollover cables. Whereas straight-throw cable is used to interconnect devices with the different types of the devices. For example, when you are connecting a computer to the switch, then you use the straight-throw cable. Or when you connect switch to router, then you use also straight-throw cable. And so in interconnectivity between different types of devices, we are using the straight-throw cable. When we are making connectivity between the same type of devices like PC to PC, or switch to switch, or router to router, or PC to router, you may ask why we are making the crossover connectivity between PC and router, because they are different. But I didn't mention maybe before, but actually router is the computer with the limited functionality, and the router is classified as the PC, as the computer. And the rollover cable is used to and it's called sometimes, mostly it is called console cable, and is used to interconnect the PC to the router or to the switch or to any type of the networking equipment which you want to manage. So rollover cable is used to manage devices. It is actually console cable. What are differences between the trace-through and crossover cable? And by the way, these rules, which I mentioned on this side, have to be satisfied in case when you have a 10 megabits per second Ethernet or 100 megabits per second Ethernet. So when you have 1 gigabit per second Ethernet or higher, then you don't have to follow these rules. You can use any kind of cable to interconnect PC to switch or to router to switch and so on. Let's take a look for the different types of the cables. They are trace-through cable. This connectivity A to A or B to B. What does it mean? It means that you have a cable with two connectors, and from one side there will be T568A, and from another side it will be T568A. Or it can be cable from both sides. It will be B and B. Then this type of cable is called the through cable. When you have such kind of cable in which you have from one side A and from another side B, imagine that this is one single cable and different pins are connected into different sequences. Then what is going on? First pin is connected from one side and it is interconnected to third pin, and second pin connects to sixth pin. And let me change the marker. And first pin connects from here, connects to pin number 3. And where is fourth pin? And I'm sorry, not fourth pin. And the second pin connects from here and goes to pin number 6, like this. So you have a cross, and that is why it is called actually crossover. And let me tell you this thing. That when you have a cross cable, what happens actually? Pin number 1 and pin number 2 are transmitting pins. They are sending information, so that your information goes like this and like this. And pin number 3 and pin number 6, so they are receiving pins. They are getting this information. And from the other side, pin number 1 sends information to pin number 3 and like this, and pin number 2 also sends information to pin number 6, so that pin number 1 and 2 are transmitting pins. Pin number 3 and pin number 6 are receiving pins. And when you have speed of the Ethernet of the 10 or the 100 megabits per second, in this case your pin number 4, pin number 5, pin number 7 and pin number 8 are not in use, so you can take them off from this connector and you will still have your proper communication with the speed of 10 or 100 megabits per second. Alright, and this is how your cable, UTP or STP cable, have to be connected to the RJ45 connector, so that the outer jack has to be inside the plastic box of the RJ45 connector. So, and this is bad example of how you can interconnect your cable into RJ45 connector, due to that fact that here you have a dangerous zone, so the pins can be damaged. Okay, And bad example, good example. Right, coaxial cable. It's like a TV cable nowadays, but before it was used in the token ring. When computers being connected to each other in the ring, and they being communicating by the schedule. Alright, and the STP shielded twisted pair is the same as the UTP cable, but it has the additional protection, which is done from foil. STP prevents interferences and the fiber media. What are the advantages of using the fiber media? There is no interferences, no electrical interference. Another advantage of the fiber media, it can provide the connectivity for very long distance. And disadvantage that it is very fragile. Okay, it can be damaged very easily. And we have these are actually advantages, and also it can provide high speed. And this is how the fiber optics is looking like. It actually has the core, which is a very small one. It is measured with the nanometer, so it can be 9 nanometers or it can be 50 nanometers. It depends on the type of the cable. It can be like a single mode, or a multi-mode. So that in single mode your signals will you will have just only one signal which is traveling inside your cable, inside your core, and the multi-mode where there can be different signals which are traveling for both sides with different angles. Alright, these are some connectors of the fiber optics, like an ST connector, SC, duplex multimode, and single mode. Now it's time to speak about the data carrying capacity. Data carrying capacity is measured with the bandwidth, throughput, and the goodput. So let's take a look firstly to the bandwidth. The capacity of the media to carry data is described as the raw data bandwidth of the media. And the bandwidth is typically measured in kilobits per second or megabits per second, or even with the gigabit or terabit per second. So the bandwidth is the maximum data carrying capacity of your media, and maximum theoretical. You will never gain your bandwidth in real life. And here how the bandwidth can be evaluated: bits per second, how many bits per second can be sent or received, kilobits, thousands of bits, megabits, millions of bits, gigabits, and the terabits per second. So when you have 1 terabit per second, then you have so many bits per second that can be sent or delivered. What is throughput? The throughput is equal to bandwidth minus device delay. What does it mean? It means that, do we have this? No, we don't have slide for it. It means that when computer A and computer B are making communication between each other, they are interconnected usually by some intermediary devices. For example, it can be a situation like this. So computer A makes encapsulation and sending the bit code to the switch. So when computer A is making this, is generating the signals, it takes time. When signals are traveling to the switch and switch makes switching, it also takes time. When signals goes to rotor and rotor makes decapsulation till layer 3, it also takes time, and signals travel to the switch again, and it takes time, and signals are traveling to computer B, and when computer B receives them, it takes time also. So all of these times are called device delay. So devices are providing the delay. So when you have a speed of bandwidth is 100 megabits per second, for example, minus this device delay will be your throughput. So let me write this one minus device delay is equal to throughput. This is not division, this is minus. And as a result, we may have, for example, just an example, 80 megabits per second is going to be our throughput. Then afterward, what is the good put? Good put is the throughput minus protocol overhead, which is actually showing your real network speed. And what does it mean, the protocol overhead? Imagine that your computer is sending this information, but before sending it, your computer will make the encapsulation from layer number 7 to layer number 1. And when this encapsulation will be happening, first of all, we had with you data. Afterward, our data is changed and became the segment. Segment is a little bit bigger than data, and afterward packet is a little bit bigger, and the data link is a little bit bigger, and afterward we have the bit code, which is also a little bit bigger. So as the result, we are sending this value instead of sending this value, and when we will receive this information, it will be decapsulated, and decapsulated till the PDU of the data. So as a result, we will receive with you this value, but we are sending this value. So this additional value is called the protocol overhead. So this is protocol overhead. It means that this additional information which is required to be added to your transportation by the different protocols. And this is actually what good put is looking like. The good put is equal to throughput minus protocol overhead. And this is the end of the chapter of the physical layer of OSI model. I hope that this video lesson been informative for you. In case if you have any questions according to this or previous lessons, do not hesitate to contact me by these email addresses. And thank you for your attention.